Next up, I want to talk a little bit about the legend controls. So over here on the left, you can see that we have the legend that's automatically displayed for us. Now let's say you find that there's too many values here and too many colors. You can always click on one of these colors and then click on the minus sign here to either remove or the plus sign to add colors to the legend. So let's say we want to remove this, we can click on the minus sign and now we've removed that color from the legend. We can click on the plus sign and then we get it back again. Now the minimum and maximum values are fixed. However, you can change the other values in between the legend. So let's say you don't want this value to be 0.015, but rather to be 0.010. You can go ahead and enter that here by double clicking on it and then clicking on enter. Another way of doing this is mousing over in between two of these colors, clicking and then dragging this up or down to change the scale. You can also right click on the legend here and choose custom colors. You can also name your legends. You can choose whether to have it vertical or horizontal, to have the date and time included. You can have the max and min on the color bar. You can choose to change the scale and many more options. There's also a useful one called semi-transparency, which adds this little semi-transparency here so you can see the legend more clearly for the report generation. Now let's say you made a change and you're not so happy with and you want to go back. You can always right click on the legend and click reset all. This will reset the legend back to the default state. Now I want to talk a little bit about the animation toolbar at the bottom here, which allows you to play, pause, and stop animations. So as you can see here, by default the animation is stopped, and if we want to play the animation, we click on this button right here to see what it does. Now as you can see, the animation is currently playing. Now as mentioned before, steps 0 to 1 is applying the pretension, and then steps 1 to 2 is applying the force. Now I'm going to go ahead and stop this. Now the two buttons next to the stop button are called distributed, and the other one is called result sets. The distributed is really for static analyses, where the frames are displayed as linearly interpolated results. The result set is more suited for transient or nonlinear problems, which is not in our case. Next to that, we have frame markers, where you can add markers to see where the frames are being plotted. And right next to that, you can select the number of frames used in the animation. And next to that, we have the desired amount of time for the entire animation. So let's say we want to change this to, let's say, 30 frames. We can go ahead and do that and put it at 4 seconds. And let's see what that gives. So as you can see, it's a much slower animation. We have much more frames, and the whole animation is taking 4 seconds to complete. So let's click on stop. Now if you want to export this video, you can also do that by just moving this over a little bit here to get more information. And there's a button right here called Export Video File, which saves the animation as an AVI file. And right next to that, we have something called the Zoom to Fit animation, which when turned on, Mechanical will loop through all the time steps to compute an auto scale factor that will accommodate the displacement for a full range of time steps and ensure that they will fit nicely onto the screen. Now let's say you want to create a section plane of your model. You can go ahead and click on this button over here to create a new section plane. So click on that right now. Now let's say you want to have a nice section plane. We can click on this Z normal right here to look normal to it, and then we can drag a line from, let's say, clicking the left side all across to the right and then releasing the click, and then there you have your section. Now you can see at the bottom left here, it created a section planes window, and section plane 1 is checked, which means that it's currently turned on. You can uncheck it to remove it and always check it back to section the model again. Now if you want to make another section, we can click on the section plane button again, and now we can section it, let's say this way, and then unclicking, and then now you can see we have a composite section, so two of the sections are now active. Keep in mind the section planes are sensitive to how you drag your section line. If I drag it from left to right or right to left, it makes a difference. So let's delete these with two right here just to show you what I mean. Let's say I click on a new section plane and drag from right to left, you'll see that it removes the bottom half of the model. If I delete this and make another one from left to right, you'll see that it removes the top half of the model. Now you can also change this after the fact by clicking on the section plane 1 here, and then clicking on this button here, which is Edit Section Plane. Now after clicking on Edit Section Plane, you'll see now if I move my mouse into the graphics window, a line appears with a little box in the middle. Now if I want to change the side of the section, I can click on this arrow over here, and it'll flip it to the other side. And if I click on this line right here, it'll revert it back to what it was before. I can also drag the square up and down to move the section manually as well. So as you can see here, if I want to move it up a little bit, I can just drag this and then let go. Now let's say you actually want to show the elements here and not have a smooth cut. You can click on this button over here, which is Show Whole Elements. So now as you can see, if I zoom in, it's showing the whole element, so it's not cutting it flush as it was before. So if I drag the slider down, you can see how that changes. Now let's remove this section plane by clicking on it right here and clicking on this Delete Section Plane. and let's close it out right here. Next up, I want to add the safety factor. So to do that, I'm going to click on Solution, and now I'm going to go under Tools and click on Stress Tool to add a stress tool into my solution. Next, I'm going to click on the plus button over here to expand this, and as you can see by default, we have Safety Factor. If we click on it, we can see that the geometry is scoping all the bodies, and it's going to show us the last step, which is after pretension and after the force is applied. Now, if we click on the stress tool here, we can see that it's using the max equivalent stress theory. We can also change that to max shear, max tensile, or more Coulomb stress for brittle materials. But because we're using steel, we're going to keep this as max equivalent stress theory. Now the stress limit type, we can change that as well from tensile yield per material, tensile ultimate, or a custom value. So normally brittle materials don't have a yield point, so in that case you'd use the tensile ultimate as the stress limit type. But in this case we're using steel, so we're going to use the stress yield per material. Now this will go ahead and fetch the yield that we've entered in the engineering data. However, if you want to override this value, you can also enter a custom value by clicking on this here and entering your own stress limit value, let's say 250 megapascals, and hitting enter. Now to generate the results for the safety factor, once again click on it, right click, and click on Evaluate Results. So right away ANSYS gives you a plot here on the left from 0 to 15. And we have a marker here indicating 1.49, which is the smallest safety factor calculated in the model, which is actually unacceptable according to US and Canadian standards. Normally for lifting or safety equipment, a factor of safety of 5 is usually the minimum that's required. So let's try to see where ANSYS is showing us this minimum factor of safety. As we can see, it's appearing somewhere near the bolt. Let's change it from the exterior view to capped isosurfaces. So now we can see exactly where this is occurring, and the lowest factor of safety is really right where the bolts are and where the pretension elements are. Let's put this back to exterior for now. Now that we've covered the basics for viewing the results, let's move forward now to the topic of scoping results.